Welcome to Ask and Learn.
We have a bunch of capacitors set up something like this, with one here, one in the middle, like this. So this is between points A and B. And now I'm going to label these C1, C2, and C3. So this is C1, C2, C3, and then these two are the same as C1 and C2. So as the problem suggests, I'm going to write the voltage from A to B. Well, let's see, I can take a couple different paths. I can take this path, I can take this path, or I can take this path. So for the middle path, that would be, I can do it as a sum of voltages for each capacitor. So the voltage is charge over capacitance. So Q2 over C2 plus Q3 over C3 plus Q1 over C1. And then I can do the same for the bottom path. So that's Q1 over C1 plus another Q1 over C1. And I can do the same for the top path, which is Q2 over C2 plus another Q2 over C2. So all these three expressions have to be equivalent because they all sum to the total voltage. So if I look at the first and second equation, I can deduce that Q1 over C1, because I have this and this, so then this Q1 over C1 has to equal Q2 over C2 plus Q3 over C3, that combination. And then looking at the first and the last equation, we have Q2 over C2 and Q2 over C2, so this one has to be equal to these two. So Q2 over C2 equals Q3 over C3 plus Q1 over C1. So now I'm going to solve for Q3 over C3 in both cases. So for the first one, this is going to be Q1 over C1 minus Q2 over C2. And for the second one, we get Q2 over C2 minus Q1 over C1. But this is just the opposite of the first one, so this equals minus Q3 over C3. So if Q3 over C3 equals minus Q3 over C3, that means Q3 over C3, the only way that can be true is if it's 0. And that's the voltage across C3, which is this middle capacitor. So if there's no voltage through the middle capacitor, then we can completely disregard it for the equivalent capacitance. And now we have something that looks like this. So we have two capacitors in parallel, which are these two. And then the other two at the end are also in parallel. So that looks like this. And now we have something that's pretty easy to figure out. So this is 4 microfarads. And the bottom two are each 2 microfarads. So we can combine each pair of these because they're in parallel. So 4 plus 2, that's going to be 6 microfarads. And now we can rewrite this once more with just 2 capacitors in series. So this is 6 and 6. And now the equivalent capacitance for that is going to be the product of the two, and then divide by the sum since we're in series. And that gives us expectedly 3 microfarads, because whenever you combine two capacitors in series, if they're equal, you're just going to get half the total capacitance. So the equivalent capacitance of this whole circuit is 3 microfarads.